Welcome back. Today I've got a vehicle here in the shop that needs a wheel bearing replaced, so I figured I'd walk you through that and get into some of the stuff that you end up doing on these things in a rusty northern climate. This Tahoe is actually in really good shape, but I expect this wheel bearing to still be rusted into the knuckle and fight on that stuff. Let's start out with looking at the wheel bearing and showing you how I diagnosed this. The car actually came in for a noise complaint, but not the noise that is commonly associated with a wheel bearing. It had a knocking or clunking type of noise. Normally wheel bearings, when they go bad, make like a whirling or a fan type of noise. These GM products of this vintage tend to not do that. They just fail and your tire tries to fall off. When I jacked this SUV up, the first thing I did was check for play. And there's play in both directions. And I'll grab the camera and bring it in here. Now what you want to do is you want to watch the difference between the rotor, which let's see if I can get in there, the rotor, which my finger is touching right now, and the caliper bracket. The caliper bracket is hooked to the steering knuckle. The rotor is actually hooked to the outer part of the wheel bearing. So if there's play in the wheel bearing, those two will move independently, and I'm not sure how well it'll show up. You can see that they're moving independently. That means that there is play in the wheel bearing itself. As long as the camera stays where it's at, that should be a pretty good spot for you to see what's going on for a lot of this. So we'll start out by removing the wheel. Next thing we'll do, once the wheel assembly is off, we'll inspect the brakes, which these look relatively new. So we won't do too much here. What I usually do in this case is I go for the rotor, the finned part of the rotor with the small pry bar. And just give it a little bit of pry in front of each piston. That gives it a little bit of room so you can slide this off. So on the back of this caliper, we've got two bolts. We've got the caliper pin bolts and the caliper bracket bolts. There's not really a good reason to remove these if you're doing a wheel bearing. Now before you remove the bolts that hold this caliper and bracket, you want to have a way to hold the caliper assembly up. I'm going to use mechanics wire, and I will hook it through this coil on the coil spring here. And actually before I do that, I'm going to disconnect the ABS wire. So in this case, this ABS wire runs right where I'm going to be hanging the caliper and will need to be disconnected. So I'm just going to go ahead and disconnect it before we get started here. Oop. So that pops apart. Now that's out of my way, so I'll be able to use the mechanics wire more easily. Okay. Now you don't want to let go of this, because if the caliper hangs by that hose, it can actually wreck the brake hose. So I got that loose. Bring it over to the mechanics wire. Twist that up a little bit. This is a T30. It was a little bit tighter than what the screwdriver version of this would do. So we'll switch over to the ratchet or socket style Torx bit. Take our rotor, set it off to the side in a nice safe clean place. Alright, our next move here is to use the impact wrench again with our axle nut socket. This one happens to be a 35 millimeter. And that nut that we just removed there holds the axle shaft into the bearing. And this one's stuck in the socket. So, there we go. Now, the axle shaft here is actually nice and loose, but if you have to, you can use a punch style bit in your air hammer to kind of drive that and loosen the splines. But that one moved nice and easy. Another thing you want to take note of while you're right here is the backing plate. Look at where it's at so you can put it back in later. Now I'll just finish removing the ABS wiring. So that's totally free and will come out with the bearing now. If we're lucky, somebody's done this bearing not too long ago and it actually comes loose. But on a 15-year-old vehicle in Michigan, if they haven't, it's going to be rusted into the hub. Okay, I'm going to use the 15 millimeter on a 1/2 inch drive because these tend to be stuck a little bit. Get that straightened up real nice in there. That. Okay, there's that one's moving. You can use the impact for these with extensions and wobbles and stuff like that, but I find it's usually just as fast to just put a regular old ratchet on it and not fight that. So we'll break these all loose with our 1/2 inch. Now if you're in the south, you just grab this bearing and remove it. But in the rusty world, we're gonna have to break the rust that's holding the bearing into the knuckle. Now you need a good air hammer to do this. Your cheap ones generally don't. But what you can do is you can actually hit the bearing on this ear and this ear and try to spin the bearing, and that usually works pretty good to release it. So I'm gonna go ahead and pop my hearing protection on because this is a good way to screw up your eardrums. And I'm going to hammer, yeah, I'll hammer on this side because there's more room. And hopefully it will start to move. And I don't know if you're going to be able to see this, but you should be able to see the bass moving. Okay, once you go a little bit, bring it back the other way. And once you divot this in a little bit, you can then tilt the air hammer and help drive out as it spins. Okay. And there, it just started to move easy. So now, I can take this, work it out, push on the lines, and our wheel bearing is loose. Now the reason that we had to hammer that out is because of this rust inside the steering knuckle. So here's the difference between somebody that's going to do this in a really nice way and somebody that's just going to slam it together. I could put this back together right now, torque everything down, and it would more than likely go in far enough, seat well enough, and be fine. But because I'm not like that, I'm going to use this Dremel, or I'm going to use this die grinder. The carbide bit is a little bit aggressive, so be really careful if you're going to do that. I actually like the flapper wheels, but I don't have one right now. So this is an iron knuckle. It'll be all right. Using one of these in aluminum can get a little bit aggressive pretty quick. But I'm just going to take this rust out of here so the new bearing, one, sits in better, and two, comes out easier next time if it ever needs to be removed again. You really should, and I would wear a respirator, but I don't have any because of the COVID thing. It's really hard to get those, and I'd like to be wearing one right now because this rust dust is not good for you. The goal here is not perfection. There's rust pits still in there, and you don't want to open this up too much or the bearing actually gets loose and it doesn't seat quite right. So now what I'm going to do is I'm not going to pick the camera up again after this. I'm going to go ahead and I'm going to use anti-seize in here. So if I ever have to remove this bearing again, it will come out. Same thing on these splines. You can see they're starting to get some rust on them. If I put some anti-seize on there now, it shouldn't seize up, and it should be able to be removed later if it needs to be. Now I take my bearing and my backing plate, and trust me, someday you will get one of these all the way back together without the backing plate on it. But right now we're going to take our bearing and our backing plate. Make sure you don't pinch this wire at all. Set it off to the side. Insert our bearing, grab one of our bolts that goes in from the back side, Line everything up. Okay, grab your other 2 bolts. Do not tighten that. You want to have a little bit of play in it so you can get the other ones lined up. I will be torquing these, but for right now I'm just going to tighten them up evenly with a 3/8 ratchet. And the torque spec on these is 133. So I'll be able to crank these about as hard as I can with the 3/8 and not be in danger of over tightening them. All right, now I'm going to torque all 3 of these. There's 1, 2. All right, so that's all 3. I like to go back and recheck the first one I did, and that one didn't move, so we're good. Now we will reinstall our axle nut, but I'm not going to tighten that yet. I'm just going to thread it on there, and I'm going to leave it really loose so it's obvious that it's not tightened. I'm going to take a little bit of anti-seize, run it around the hub area here, so that the next time that brakes are done, they come apart. Now, we're going to take our rotor, line it up so that our hold down bolt can be threaded back in. Snug that up. Nothing crazy, just snug. Now if you in any way touched this rotor, the face, while you were moving it, you should clean it now before you reassemble everything. I was really careful not to touch either side of this rotor because it came off really easy, so I could do that in this case. Now I'm going to grab my caliper. Whoops. Take our caliper bolt. Start the top caliper bolt several threads. Grab the bottom caliper bolt. Tighten these up. That one is also now snug. And these 2 bolts get torqued to 148 foot-pounds. 1, 2, and there we go. So those are torqued to 148. Now I grab my screwdriver I don't care too much about, and I'm going to insert it into the fins in between the rotor and this bracket. So as I go to tighten this center nut, it will hold the assembly in place. This impact actually has a low torque setting, which is supposed to go to less than 100 foot-pounds, or right around 100. This torque on this nut is supposed to be 177. So I'm going to go ahead and run it in with this, but otherwise, if I didn't have that low setting, I would just do this by hand as well. All right, that quit moving, which means it should be at about 100 foot-pounds. Turn our torque wrench up to 177. Okay, so there's 177. Okay, that click means that it's torqued. There we are. So now we have torqued the wheel hub to the knuckle, the caliper bracket to the knuckle, and this center hub nut. Now, according to our bearing manufacturers, torque on this center hub nut is one of the leading causes of failure on aftermarket wheel bearings. So we want to make sure that we get that torqued appropriately. So there we are. Now I'm going to go ahead and reroute my ABS wire, plug it in. Okay. So now we've got our ABS wire rerun. Reinstall the wheel. Put our lug nuts back on. I'm going to use the low torque setting again on these Now, one of my pet peeves is that car shows always just run everything home with an impact. It never shows anything being torqued. And I'm going to go ahead and do that, but this wheel is, I haven't looked up the spec yet, but it's going to be at least 120. It's probably 130 or 140. So this is not going to over torque it, but it will snug the wheel up. Okay, so there's 1, 2. The wheels are snugged up, but not torqued yet. So I'm going to lower this vehicle down to the ground to where the tire just touches the ground, but doesn't put any weight on the tire yet. Okay, the torque spec on these wheels is 140 foot-pounds. So I'm going to go ahead and do that in a crisscross pattern. And then I always go back to the first one to make sure it doesn't move. And if the first one moves, go back through the pattern again. Now on this particular vehicle, I did not road test it before I did this bearing, because when I checked the wheel bearing, it made me nervous to take it out on the road. It was kind of at that point where it could have failed at any minute, in which case you're doing damage to the brakes and risking the wheel actually falling off, which would be bad. So I have not driven this yet. I'm going to go ahead and leave the hubcap off while I test drive it, and then I will recheck these lug nuts, and this one will be done. So that's it. That's how you change a unit hub style bearing. We did this on a Tahoe today, but it's really about the same on almost any car that has that style of bearing. So thanks for watching, and I'll see you later.